Hello students, this is Dr. Anita Raj, your chemistry mentor, welcoming you for a new session in some basic concepts of chemistry. Actually, in this session, I would like to teach you the easy tricks to calculate oxidation number or oxidation state very easily by mentioning only 6 rules instead of using the normal and boring 15 to 20 rules which you are learning in your schools and colleges. At the end of this lecture, I would like to teach you to do the exam-based problems to calculate the oxidation number of elements, ions and molecules very easily. Well, let us start the session now. By the way, what is oxidation number or oxidation state? It's the charge assigned to an atom, ion or a molecule. By the way, you should never confuse this oxidation number with oxidation state because both are one and the same, okay? For example, H0, H minus 1, Na0, Na plus. Okay, so we know that this Na and H0 are neutral atoms, so the apparent charge on them are 0. Okay, on Na plus and H minus ions, the apparent charge on them are plus 1 and minus 1 respectively. Similarly, we can take into account Fe0, Fe2 plus and Fe3 plus. See, the oxidation number of this neutral Fe is 0, whereas this ion Fe2 plus is plus 2 and Fe3 plus is 3 plus. Okay, so these are the different types of oxidation numbers we have for ion, right? So now we shall see the rules used to calculate the oxidation number of atoms, ions and molecules. So the first rule is elements in their free state or elementary state, that is copper, iron, sulfur, sodium, or gases in their elementary state is 0. See, for copper, iron, sulfur, sodium, these elements are found to be in their free state or in the elementary state. So the oxidation number for these elements, that is copper, iron, sulfur, sodium, which are in their elementary state or in the free state, is found to be 0. Okay, likewise for those gases which are in their elementary state, their oxidation number will be 0. So this is the first rule which you should be thorough with, right? So the second one is, in the charged state, the oxidation number of ion is the charge number. Okay, see here, this is an ion Na plus, Zn2 plus. Okay, so these elements are in their charged state, so they are called as ions. So what's the oxidation number of these ions? That's the charge that is present at the top, right? So the charge on the ion will be the oxidation number of that particular ion. Okay, so for Na plus, the oxidation number is plus 1. For Zn2 plus, the oxidation number is plus 2. Can you understand? So the oxidation number of a monoatomic ion is equal to the charge on it, right? So Na plus means the oxidation number will be plus 1. Okay, so the next important rule is oxidation number for hydrogen is always plus 1. Okay, so oxidation number of hydrogen will be always plus 1 except in metal hydrides like calcium hydride or sodium hydride, whereas here in this case, in these cases, in metal hydrides, the oxidation number will be minus 1 for hydrogen. In all the other cases, the oxidation number will be plus 1 for hydrogen. Only for the metal hydrides like calcium hydride and sodium hydride, the oxidation number will be minus 1. Okay, so the next important rule is the oxidation number of oxygen is found to be minus 2 in all compounds except in peroxides, H2O2, Na2O2. Here we have the oxidation number as minus 1, and whereas OF2 it's plus 2. Can you understand? So there are 3 different types of oxidation numbers for oxygen in except for peroxides, H2O2 and Na2O2, and also for OF2. All the other compounds, the oxidation number is found to be minus 2 for oxygen. Okay, whereas for hydrogen peroxide and Na2O2, the oxidation number is found to be minus 1. This you should not forget. Okay, so whenever you are getting a problem with this hydrogen peroxide or sodium peroxide, you should make use of this number minus 1. Okay, then for OF2, the oxidation number is plus 2. Can you understand, students? So for oxygen it is minus 2, right, in other compounds, right? Next, for oxidation number of halogen is minus 1. So wherever we are finding this halogens, we can substitute the value as minus 1 for the oxidation number. Okay, and the next one is oxidation number of the 1A, that 1A, first A group. Okay, so that is the alkali metal is plus 1, whereas for 2A, that is alkaline earth metal, is plus 2. Okay, that's very important, right? Then how to find out the oxidation number of a molecule? So the oxidation number of a molecule is the algebraic sum of oxidation number of atoms in the molecule. Okay, this how to find out. See, let me explain how to find out. See, for example, just consider the type of compound XY. So the compound given is XY. If it is so, how to find out the oxidation number? See, the algebraic sum of X plus Y is equal to 0. Since it is a neutral compound, it's a neutral compound, we are giving the algebraic sum as 0. Okay, so for example, the next type, that is AB2. See, if the compound type is like this, then how to calculate A plus 2 into B equal to 0. Okay, for ionic compounds A, B minus, okay, if it is so, then the algebraic sum is A plus B is equal to minus 1. So this is the final rule. So this is the format which you should follow to calculate the oxidation number of various types of compounds and ions. Can you understand? Now, using these rules, it's possible to calculate the oxidation number of elements, ions or molecules. Let me start with simple examples right now, okay? First one is find out the oxidation number of Mg in MgO. See, they are asking you to calculate the oxidation number of Mg in MgO, okay? So, this is the simplest one. So, let me write like this, Mg plus O is equal to 0. It's a neutral compound, is it not? So already we know that oxidation number of oxygen in the other compounds, okay, it's not hydrogen peroxide or sodium peroxide or OF2, it is MgO, it's a normal compound. So here the oxidation number of oxygen is found to be minus 2. So Mg plus minus 2 equal to 0, and we are in need of the oxidation number of magnesium, so Mg is equal to plus 2. So this is how you should find out the oxidation number of magnesium in magnesium oxide. Okay. So let us see the next one. Find out the oxidation number of K, that is potassium, in K2O. So this is also a neutral compound. So K2O is a neutral compound. Okay. It's a neutral one. It's not an ion. So it's a neutral molecule. So how to find out this one? 2 into K plus oxygen is equal to 0, is it not? So 2K plus, what is the oxidation state of O? It is minus 2. Oxidation number is minus 2 is equal to 0. Okay. So 2K is equal to plus 2. Then K is equal to plus 1. Is it not? Plus 1. So the oxidation state of K in K2O is plus 1. Understood, students? Next we shall see the medium level. In medium level, oxidation number of N in NO2 minus 1. See, this is an ion, is it not? They are asking you to find out the oxidation number of nitrogen in NO2 minus 1 ion. So it's an ion. So how to write down, right? See here, N, this is not a neutral molecule, it's an ion. So what's the format? N plus 2O is equal to minus 1. So this is the format. Okay. See here, as I told you earlier, X, Y minus life. If it is the format, then how to find out the oxidation number? The algebraic X plus Y is equal to minus 1. So this is the format. Okay. So we are following that one, right? So N plus 2O is equal to minus 1, right? So we are supposed to find out the oxidation number of nitrogen. N plus 2 into minus 2 is equal to minus 1. N minus 4 is equal to minus 1. So N is equal to plus 3. Okay. So the oxidation number of N in NO2 minus 1 is plus 3. Can you understand? Now find out the oxidation number of nitrogen in NH3. Okay. So NH3, it's a neutral molecule obviously. So N plus 3H is equal to 0, right? So N plus 3 into hydrogen, what is the oxidation number? It is plus 1, is equal to 0. So n plus 3 is equal to 0. N is equal to minus 3. So the oxidation number of nitrogen in NH3 is minus 3. Okay. See here, nitrogen is having plus 3 in this case. Nitrogen is having minus 3 oxidation state in this case. Is it not? Next, oxidation number of phosphorus in PCl5. Okay. So it's a halogen. Okay. Is it not? So now PCl5. PCl5. We are supposed to find out the oxidation number of phosphorus. So phosphorus plus 5 into Cl is equal to 0. Now phosphorus plus 5 into, what is the oxidation number of chlorine? See, the oxidation number of all the halogens is minus 1. Is it not? So that's the rule, right? That's the rule which we have learned, right? So P plus 5 into minus 1 is equal to 0. So P minus 5 is equal to 0. P is equal to plus 5. Is it not? P is equal to plus 5. So the oxidation number of phosphorus in PCl5 is plus 5. Okay. Already we have seen that in rule number 4 that oxidation number of halogen is minus 1 in all halogen compounds. Is it not? So using that we have found out the oxidation number of phosphorus here. Okay. Now let us see some exam based problems. Okay. Oxidation number of carbon in carbon monoxide and carbon dioxide. So they are asking you to find out the oxidation number of carbon in two compounds, that is carbon monoxide and carbon dioxide. Okay. So let us find out the oxidation number of carbon in carbon monoxide first. CO. So C plus O is equal to 0. C plus minus 2 is equal to 0. So C is equal to plus 2. So the oxidation number of carbon in carbon monoxide is plus 2. Okay. So let us say the oxidation number of carbon in carbon dioxide. So C plus 2 into oxygen is equal to 0. C plus 2 into minus 2 is equal to 0. C minus 4 is equal to 0. So carbon is equal to plus 4. So the oxidation number of carbon is plus 4 in the case of carbon dioxide. So the compounds are different. In different compounds, carbon is having different types of oxidation states. In carbon monoxide, it is plus 2. Oxidation number of carbon is plus 2. Whereas in carbon dioxide, the oxidation state of carbon is found to be plus 4. Okay. So next compound, oxidation number of carbon in calcium carbonate. They are asking you to find out the oxidation number of carbon in calcium carbonate. Okay. So calcium carbonate, CaCO3. So Ca plus carbon plus 3 into oxygen is equal to 0. Is it not? See this calcium is an alkaline compound, alkaline earth metal. Calcium is an alkaline earth metal. So for alkaline earth metals, the oxidation state is found to be plus 2. Is it not? Plus 2. So I'm using that rule here. So the oxidation state of the alkaline earth metal is found to be plus 2. So calcium I have substituted plus 2 here. Okay. Calcium I have substituted plus 2. Now plus carbon plus 3 into, what is the oxidation number of oxygen? It is minus 2 is equal to 0. So plus 2 plus carbon minus 6 is equal to 0. So carbon is equal to plus 4. So the oxidation state of carbon in calcium carbonate is found to be plus 4. Understood, students? The next important question is to find out the oxidation number of phosphorus in H3PO4, phosphoric acid. They are asking you to find out the oxidation number of phosphorus in phosphoric acid. Okay. So the formula is, let me write here, H3PO4. They are asking you to find out the oxidation number of phosphorus, right? So 3 into H plus phosphorus plus 4 into oxygen is equal to 0. Okay. So 3 into, what is the oxidation number of hydrogen? It is plus 1. Okay. Plus phosphorus plus 4 into minus 2 is equal to 0. Okay, so 3 plus phosphorus minus 8 is equal to 0. Is it not? So phosphorus is equal to plus 5. Okay, so the oxidation state of phosphorus in phosphoric acid is found to be plus 5. Can you understand? The final question is oxidation number of Mn in KMnO4. They are asking you to find out the oxidation number of Mn in KMnO4. So KMnO4. Okay, so potassium, it is an alkali metal, just 1A group. Okay, so the oxidation number already in the rule I have given for 1A group, the oxidation number of the alkali metals is found to be plus 1. Is it not? Plus 1 plus Mn plus 4 into oxygen. Is it not? Oxygen is equal to 0. So plus 1 plus Mn plus 4 into minus 2 is equal to 0. So plus 1 plus Mn minus 8 is equal to 0. So Mn is equal to plus 7. So the oxidation number of manganese in KMnO4 is found to be plus 7. Well, fine students, I hope you might have understood what I have taught today. Let me meet you with another important topic in my next session. Until then, it's Dr. Anita Raj, your chemistry mentor, signing off from you. Thanks for watching.